Well, because of the whole coronavirus, we are a little bit behind schedule, so we're going to skip chapter 8 and start on chapter 9. Rational numbers, that's another word for fractions. Which, if you think about it, this is sort of funny because I drew a line right there and it's making a fraction out of the rational and the fraction. Okay, anyway, I found it funny. So fractions could be anything like 1/3, negative 14 over 5, 12. 12 is a fraction because 12 is 24 divided by 2. Or 12 is 12 divided by 1. So any whole number is also a fraction. Even 0, because 0 divided by 12 is equal to 0. So 0 can be viewed as a fraction. And then there's even mixed numbers like 4 and 1/5. So one important thing with fractions is being able to simplify. So how about if it was 14 over 88? So to simplify, notice that this is an even number and this is an even number. So that means that each one could be divided by 2. And on the top, 14 divided by 2 is 7. 88 divided by 2 is 44. And with that being a 44, a 7 will not divide into it, so that means that this one is already done. How about negative 200 divided by negative 150? Well, a negative divided by a negative is a positive, so these two negatives are going to cancel each other out. Also, you could divide by 10 and divide by 10 and then get a positive 20 over a positive 15. And when numbers end in 0 or 5, that means they can be divided by 5. So divide the top and the bottom by 5. And then it's going to leave 20 divided by 5 is 4. 15 divided by 5 is 3. And this cannot be reduced anymore, so that one is finished. And then for adding or subtracting fractions, the denominators need to be the same. So for example, number 3, if it was 3 over 107 plus 4 over 107, then that equals 7 over 107. But the denominators need to be the same. If they're not, then you need to get them to be the same by multiplying the top and the bottom by something. So for example, number 4, if it is 2/5 plus 7/3. So to get a common denominator, you need to look at the multiples of 5. So there's 5 times 1, 5 times 2, 5 times 3, 5 times 4, etc. And then for 3, look at the multiples of 3. So there's 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5. And as soon as you get the same number, then you stop. So that means that this denominator can be changed into a 15. And to do that, you multiply by 3. So multiply on the top and the bottom by 3. And this one will leave 6 over 15. And this one can be changed into a 15 if you multiply by 5 on the top and the bottom. And so that will be 35 over 15. And once you have a common denominator, then you could write it as one fraction with the 15 as the denominator. And then we just need to figure out what's 6 plus 35. So 6 plus 35 is 41. So it turns out to be 41/15. 41 is a prime number, so this cannot be reduced and it's finished. Now let me show you a different way to do the same problem. 2/5 plus 7/3. So it replaces doing this over here. So what you do is you multiply this with the 2. So there's 2 times 3. And then you multiply this with the 5, and as you go in this direction, you pick up whatever sign that is. In here, it's a plus. So then it's going to be plus 5 times 7. And then for the denominator, you just multiply these two. 5 times 3. So this would be 6 plus 35 over 15. And then that basically takes us to that point right there. We get the same thing, 41 over 15. Then what about if it is 3 fractions? Well, with 3 fractions, that little shortcut that I showed you won't work. So for example number 5, if it was 5/2 plus 3/8 and then minus 5/16. So this can be turned into a 16 if you multiply by 2 on the top and bottom, and this can be changed into a 16 if you multiply by 8. So all of these denominators can be turned into a 16. If your students don't see that right away, then they would need to go through what are the multiples of 2, what are the multiples of 8, what are the multiples of 16. And as soon as all 3 of them are the same, then that's the least common denominator. So this one can be changed to a 16 if you multiply by 8, but you need to do the same thing on the top and the bottom. This one, multiply by 2 on the top and the bottom. So this will be 40 over 16. Oops. 40 over 16. This one will be 6 over 16, and then minus 5 over 16. So the common denominator is 16, and I would group these two together first. A 6 minus 5 is a 1, and then add that 1 to 40 is going to be 41 over 16. Very similar to the last answer. Interesting. Again, 41 is prime, so that means that this can't be reduced, and number 5 is done. Then for the next idea, multiplying fractions. Probably the easiest function there is with fractions. So if you have one fraction, a over b, and you multiply with another fraction, c over d. Then all you need to do is multiply on the top, multiply on the bottom. So the top would have a times c, the bottom b times d, and then with all fractions, then reduce if possible. So for example number 6, how about 8/7 times 5/4. So multiply on the top, so 8 times 5. Multiply on the bottom, 7 times 4. And then reduce. Well, you could look at this as a 40 over a 28 and then start reducing. Or you could look at it as this 4 will divide into this 8 2 times. So what's left on top is a 2 times 5, that's 10. On the bottom, the only thing left is 7. And it's now reduced. So you can multiply and literally multiply it out, or you could just say it's one number times the other number and then reduce. Or you could multiply it, we would have 40 over 28 and then reduce those bigger numbers to a 10 and a 7. Then for example number 7. How much is 2/3 being multiplied with 1/2 plus 6/5? With this one, there's two different ways to do it, and I'm going to do both ways. So for part A, work in the parentheses first. So leave the 2/3 on the outside and then work inside the parentheses. So for a 2 and a 5, the common denominator is going to be 10. So this one I need to multiply by 5 on the top and the bottom. That's going to be 5 over 10. And for this one, to change this to a 10, I need to multiply by 2 on the top and the bottom. So this second fraction right here is going to be 12 over 10. And then when you add these together, that's going to be 17 over 10. And then you can write that as one fraction where it's 2 times 17 and then 3 times 10. Like I was saying with the last problem, you could write this as 34 over 30 and then reduce. But I prefer to reduce right now while the numbers are smaller. So a 2 divides into a 10 5 times. And so it turns out that it's 17 on top and 3 times 5, 15 on the bottom. And because 17 is prime, that cannot be reduced. It's finished. For part B, use the distributive property. So I'll do the same question, I'll get the same answer, but a different way. So the original problem was 2/3 times parentheses a 1/2 plus a 6/5. And then distribute, multiply those two fractions, distribute, multiply those two fractions. So when you multiply these two, the top is going to have 2 and the bottom is going to have 6. So it's going to be 2/6. When you multiply this and this last one, it's going to be a 12 on top and a 15 on the bottom. Well, this fraction could actually be reduced because the 2 could divide into the 6 3 times, or divide by 2 on the top and divide by 2, so that's going to be 1/3. And I can see that the answer is supposed to have 15 on the bottom, so I'm going to leave this one the way that it is. Then change the common denominator to be 15. So for this, multiply on the top and the bottom by 5. And then it's got a common denominator of 15. And for the numerator, this would be 5 plus 12 is 17. So a different way to do it, but we get the same answer. Now there's just two more ideas in this section. One is dividing fractions. So if you have one fraction divided by another fraction, you leave the first fraction alone, a over b. You invert the second fraction, so it becomes d on top and c on bottom. And then you change it to a multiplication. So for example number 8, if you have 2/3 divided by 4/5. So the 2/3 stays there. The 4/5 becomes 5 over 4. And then change it to multiplication. And you could just multiply on the top, so that's 10. Multiply on the bottom, that's 12. And then reduce. Since both of these are even numbers, I could divide by 2 and divide by 2. So on the top, that leaves a 5. On the bottom, it leaves a 6. Now I want to use the calculator and make sure that I got the right answer. So I'm going to put them in parentheses to make sure the calculator understands this is one fraction, 2/3. Divided by, this is another fraction, 4/5. And then most all calculators have a way to change it to fractions. So I'm going to go to math, and the first one is change the answer to a fraction. And it says you should have gotten 5/6. Perfect. Example number 9. How about 10/13 divided by 4? And then you go, wait a second, that's not a fraction. But 4 is the same thing as 4 divided by 1. So it really is a fraction. So the first fraction stays the same. Then change it to multiplication and invert the 4 over 1, so it becomes 1 over 4. So on the top, that would be 10 times 1. And on the bottom, that's going to be 52, because 4 times 10 is 40. 4 times 3 is 12, and 40 plus 12 is 52. And then reduce. Once again, these are even numbers, so divide by 2 and divide by 2. On the top, it leaves a 5. On the bottom, a 26. This cannot be reduced anymore, so it's done. And like with the last one, I want to make sure that I got it right. So 10/13 gets divided by a 4, and then change the answer to a fraction. And it says 5/26. Sorry, I don't know what's with that glare. Maybe if I hold it like this to get rid of the glare. Anyway, got it right, 5/26. And then for the last idea of the section. To cross multiply. So for example number 10, is 2/17 equal to 16/104. So you could divide this on a calculator and get a decimal, divide this and get a decimal, or you could cross multiply. And cross multiply means you multiply a 104 to that side and you multiply a 17 to that side. So in other words, is 2 times 104 equal to 17 times 16? So 2 times 104 is a 208. 17 times 16 is a 272. So the answer, no, not even really that close. And for the final example of this section, you can do that with inequalities as well. So for example number 11, is the fraction 2/17 smaller than 3/20? So the only difference is, instead of having an equals, you've got a less than. So you multiply the 20 onto that side and multiply the 17 onto that side. So 2 times 20, is that smaller than 3 times 17? Well, 2 times 20 is 40, and 3 times 17 is 51. Is 40 smaller than 51? That is true.